Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is our next problem. Problem once again having been chosen from the book Modern Physics by Kenneth S. Crane. As usual, we first come towards its statement. In order to study the atomic nucleus, we would like to observe the diffraction of particles whose de Broglie wavelength is about the same size as the nuclear diameter, about 14 femtometer. Femto means 10 to power minus 15. Femtometer for a heavy nucleus such as lead. What kinetic energy should we use if the diffracted particles are part A electrons, part B neutrons, part C alpha particles? Okay, and for alpha particles m is equal to 4u, atomic mass unit. Okay, this value we will find from table. Okay, we will introduce a tool and table introduced in that tool will help us a lot in solving this problem. Okay, in that tool electrons, neutrons and alpha particles will be dealt with. Okay, so now we move to helping tools. Okay, helping tool number 1. This helping tool has been taken many times. Okay, momentum of a photon P is equal to E over C is equal to HF over C is equal to H over lambda. Okay, where P is the momentum of a photon, E is photon energy, C is the speed of light in vacuum, H is Planck's constant, lambda is the wavelength. Okay, this tool has been repeated many times. Dear students, this second tool has also been repeated many times, but in this problem, this tool gains much more importance. The whole problem is based on the philosophy of this table. Okay, in this table, electron, neutron and 1u equal to this. All these three values will be used. Okay. Tool number 3, in this tool speed of light, speed of value of Planck's constant h will be used. Okay, anyhow, now we come towards its solution. Okay, we know that momentum of photon is given as P equal to E over C, C is equal to HF over C is equal to H over lambda, because dear students, we know that frequency and wavelength frequency f and wavelength lambda are inversely proportional to each other, reciprocal of each other with the involvement of speed of light c. Okay, so here in order to find P, we have to find value, we have to put value of H Planck's constant from tool, in which it has been given in two ways. Okay, we have chosen one way, that is in term of electron volt dot second, divided by wavelength is given in the statement 14 femtometer. Femto stands for 10 raised to the power minus 15. Okay, so in the next step we have converted femto into 10 to power minus 15. Okay, so this 10 to power minus 15 will be cancelled with the 10 to power minus 15, which is a part of the value of Planck's constant h given in table. Okay, so these 10 to power minus 15 will be cancelled and we will get our answer in terms of this. Okay, 4.136 into this will be cancelled and we will get 0.295 electron volt second per meter. Okay, the whole process has been reduced into this factor. Okay, 0.295 electron volt second over meter. In the next, now what are we going to do? Now we are multiplying and dividing it with C. Okay, there will be no difference. Okay, but the only difference is that in the numerator we are using value of C, but in the denominator we are just using the symbol C, speed of light. Okay, So after simplification, it will take the form as 88441000 electron volt over C. Because dear students, here meter will be cancelled out with meter, second will be cancelled out with second, and we will be left with electron volt over second, over speed of light C, electron volt over C. Okay. Now dear students, this is very large quantity. Okay. If we convert it, if we 1 2 3 4 5 6, okay, if we convert it into 88.441, then it will be converted into million electron volt. Okay. However, in the denominator, speed of light C will remain the same. Okay. So our one part has been solved, that is momentum P has become equal to 88.441 million electron volt over C. Okay. This value is very important. This value will be used in all the three parts. Okay. And still, dear students, we have yet not started our part A. This part is common for all the three parts of this problem, that is A, B, C. Okay. Now we are going to start part A. Okay. Now part A says that now P is equal to 88.441 million electron volt over C. This value we have calculated in above step. Okay. This implies that if we convert C on other sides of the equality, then PC is equal to this. Okay, no confusion. Also, MC square for electron is equal to 0.511 million electron volt. From where we have taken this value? We have taken this value from tool table, in which values of electron, proton, neutron and 1U are given. Okay. So I, for the time being, do not go back into that tool. I just recall that value of P we have calculated in previous step. From here value of PC has become equal to this, and value of MC square for electron, because part A is dealing with the electron. In helping tool where table is given in which electron, proton, neutron and 1U is given, their MC square is equal to 0.511 million electron volt. Okay, so when we compare these two values, so we come to conclude that this value, that is 88.441 million electron volt, is very greater than 0.511 million electron volt. Okay. So this implies that extreme relativistic expression holds. And in extreme relativistic expression, we know that energy E is equal to or approximately equal to PC, and this becomes equal to 88.441 MeV. Moreover, kinetic energy is equal to energy minus rest energy, MC square. Okay. So K is equal to E minus MC square. Okay. So K is equal to E minus MC square. And this is equal to, here in place of E, we are using this value, PC. PC equal to 88.441. Oh, this minus in place of MC square, we are using this value, which we have taken from table, which has been introduced as a tool for this problem. Okay, and hence when we subtract these two quantities, we get 87.93 million electron volt. Okay. So dear students, this value, that is 88.441 million electron volt, will be used in all the three parts A, B, C. However, the answer of part A has become equal to 87.93 million electron volt. Now we come to part B. Now P is equal to 88.441 million electron volt, which we have calculated in previous step. This implies that PC is equal to this. Okay. Also MC square is equal to this. What is this? This is actually, dear students, part B deals with neutron. Okay. We go once again, we go back. This is okay. Part A for electrons, part B for neutrons, and part C for alpha particles. Okay, and here is the table. For electron this is 0.511, while for neutron this is 939.6, and for 1u this is 931.5. Okay, because dear students, electron is a light element revolving around the nucleus, while proton and neutron are massive particles, and due to their larger mass they remain inside the nucleus as heavy particles. Okay, now we go to part B. Okay, part B. Part B, yes, this is part B. Also mc square equal to this. Okay, in part A we had dealt this value for electron, but here we are dealing with neutron. So for neutron, value of mc square in that table is given as this. Okay, so we know that this value is very less than this value. Okay, here situation is quite opposite or reverse of position of part A. Okay, this value is very less than this value. So relativistic expression does not hold, and we combine two equations, that is k is equal to half mv square and p equal to mv. Okay, these two, when we combine these two equations, then we get k is equal to p square over 2m. Okay, we have done nothing, we have just rearranged these two equations. However, in the next step we have multiplied and divided it with the c square. Okay, when we have multiplied and divided this thing with c square, then it will become whole pc whole square, while this will become 2 into mc square. Now value of pc is also given and value of mc square is also given, and hence we will put these two values. Value of pc is this whole square and value of mc square is this, and it is multiplied by 2, and hence 1 MeV from will be cancelled from this square, and only 1 million electron volt will be left, and in the numerator we will be left with this value, and in the denominator we will be left with this value. Okay, which is just double of this value, 939.6. Okay, and after simplifying it becomes equal to 4.16 million electron volt. This is the solution of part B, and now we come to part C. Okay, again P is equal to this and PC is equal to this. This is the same as in part A and B. Also, okay. Also, MC square is equal to 4U. This is given in this statement, and in the tool, helping tool, value of 1U is given. So when MC square is equal to 4U, then 4 into U. This value is given in the table which we have introduced as a tool, helping tool. Okay, so when multiplied with 4, it will become this. Okay, so here again situation is quite similar to part B, in total contradiction of part A. Okay, so 88.441 MEO, sorry students, here is a minor mistake. Here million electron volt, mistakenly V is not written. Okay, so no problem. 88.441 million electron volt is very less than 3726 million electron volt. Now again same process as in part B. Okay, these two equations have been simultaneously solved, and value of k has become equal to this, and in the next step we have multiplied and divided it with c square, and hence in the numerator we have got a PC whole square, and in the denominator 2 MC square. Now value of PC is also available, value of MC square is also available. Okay, so we just put these two values, and hence 1 million electron volt will be cancelled with million electron volt, and only 1 million electron volt will be left in the numerator, and hence after simplifying we will get the result 1.05 million electron volt, and this is the solution of part C, and this is the end of our problem and end of our video. Till next video, Allah Hafiz.